So this section is a pretty quick section. We're just working on how do we write sine and cosine functions. It's going to be similar to things we've done in the past in terms of how do you model when you have information about an equation. And it follows the same sort of process where normally we'd learn how to, say, graph a function, and then later in the chapter, in this case this section, we would learn how to take the graph and put it back into the form of the equation. So it's all again about the important key parts of the graph. When you talk about a sinusoid, so that's the that's the shape, the sine curve shape. So something that goes like this, that undulates like that, or even something that sort of follows the cosine sort of shape. So these are sinusoids, and that's just a new vocabulary for that's how you describe that shape. Okay, a type of problem I might want to do is this one where we're jumping rope and we want to figure out the different heights. So the highest point for the middle of each rope is 75 inches above the ground. The rope makes 2 revolutions per second. Write a model for the height as a function of time. So we're going to write an equation. Generally, when they say write a model, right, that means write an equation that models this situation. So before we do this problem, let's just practice doing that in general. So here is a function, right? This is a sinusoid. And what are the key parts that I want to find? So we're talking about y is equal to a times, a times the sine of x minus h plus k. As we're starting to work with this, I know that h and k would represent a translation, but if I decide that this is, say, a sine function, it doesn't look like it's been translated. It starts here at the origin. In fairness, I could write it as a translated cosine function, but why would I want to add more complexity to the problem if I don't have to? Right? So I know that h is equal to 0, k is equal to 0. That's great. So that means I'm really talking about y is equal to a times the sine of x. I'm sorry, the sine of, my mistake, I left some things out here. Sine of b, right? It's a times sine of b times x, because I need a and b. All right, so now a is going to be related to my amplitude, and b is going to be equal to my period. So if we look at the amplitude, 1, 2, 3, right? 3 is this distance here. So a is equal to 3. If I want to find b, I know that 2 pi divided by b was equal to the period. And if I look at the period, it's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, or just pi. All right, so if I multiply both sides by b, I'll get 2 pi is equal to b pi, and so b is equal to 2. And if I go ahead and write this equation out, then it's y is equal to 3 times the sine of 2x. Okay, and I could double check that, but it's not really necessary. I got all this data, right? I knew that the period was equal to pi. I know that my amplitude is equal to 3, and that's all I need to write my function. Okay, so you go ahead and practice that. Do problems 4 and 6, and then we'll do some more complicated versions of this. So now if we look at some of this information, they're just saying a sinusoid with a maximum at point A and a minimum at point B. So they're giving me some data. Well, actually, let's use the lines and do a nice job here. So they've told me a certain amount of information. Let's take a look at that. At pi 6, and so let's say we have pi, 2 pi, 3 pi, 4 pi. So at pi, I have 1, 2, 3, 4, 5, 6. Pi 6 is there. And over at 3 pi negative 6, 1, 2, 3, 4, 5, 6, there's a minimum right halfway between, right? This doesn't look like it's been translated necessarily, right? I could write it as a translated version, so actually I'm going to go ahead and do this. So I'm going to write it as a sine function, and then I'm going to write it as a cosine function. If I write it as a sine function, you can see, right, by putting in these extra points is pi, 2 pi, 3 pi, 4 pi. This could be my graph. My amplitude is 6. It's not shifted anywhere as a sine function. I know that my period, right, equals a, and my period is equal to 4 pi. That means that 2 pi divided by b is equal to 4 pi. So b is equal to 1/2. And if I want to write this as a sine function, y is equal to 6 times the sine of 1/2 x. Okay, but what if I wanted to write it as a cosine function, right? This could have been my maximum, and this could have been my starting point. Okay, so in this case, I could have written it as a cosine function. My amplitude is the same, my period is the same. But what if I was shifted forward by pi? Well, in that case, if I do it as a cosine function, h is equal to pi. Now, it didn't go up and down at all. So y could also be equal to 6 times the cosine of 1/2 times x minus pi. Right? So I could have done it either which way. Right? Both of these are correct. The key element is figuring out where we're at. How did I know that it hadn't shifted up or down? Well, the halfway point between the maximum and the minimum was at y is equal to 0. Up here I'd have y is equal to 6. Down here y is equal to negative 6. Halfway between them, y is equal to 0. So I knew it hadn't shifted up and down. Okay, as a sine function, it's non-translated. As a cosine function, I have to translate it by 1/4 of the period. So you go ahead and give that a try. Do problems 10 through 11. Come on back and we'll wrap this lesson up with the jump rope. Okay, so in this case, the highest point in the middle of each rope is 75 inches above the ground. So I have a top place of 75, and I have a bottom of 3. Okay, so the distance between those is 72 inches, and that means that the amplitude is 36, right? And then the middle point would be 36 above 3, right? 3 plus 36, so my middle will be y is equal to 39. I know that a is equal to 36. Okay, that's pretty good. I know that it makes 2 revolutions per second. So I'm worried about when I return around to the beginning, I know that my period, not my b value, but my period, is equal to, period is equal to 1/2 second, because it's where I go back around to my original starting point. All right, so that's some good information. So I know that 1/2 is equal to 2 pi over b. So b must be equal to 4 pi. Okay, great. All right, I have a, I have b, but I have to know now for me to get y is equal to 39, that's my k value has to be 39. That's what's going to shift it from y is equal to 0 all the way up to 39. All right, and then I shouldn't have any horizontal shifting that I can see. So if we start at, the question is, do we start at the bottom or do we start at the top? Well, if I'm doing jump rope, it's going to start at the bottom, right? There's no real way to start the jump rope in the middle, right? So if it starts at the bottom, that's going to be a cosine function that is reflected, right? We're going to go from the bottom, we're going to go from 3 to 39 and then back down to 3. Okay, so this is a reflected cosine function when the way I see this. So I'm going to have y is equal to negative 36, right? My a value, my absolute value was 36, but I want it to be negative 36 times the cosine, because I want to start at the lower amplitude, of b, which is 4 pi, and then with no horizontal shift, it would just be x, and then my vertical shift plus 39. Okay, it's just x because h was equal to 0, k was equal to 39, that gets added on at the end. My amplitude is here, my b is here. The way this went in is y is equal to a times the cosine of b times x minus h plus k. K was 39, h was 0, b was 4 pi, and a was 36, and we need it to be a reflection, so it's negative 36. That's how I take that data and write an equation.